1.602 times 10 to the minus 19 C. Electrons. Robert Andrew Wilkin Millikan. Density equals
Hey there. Sorry, let me turn that off. Welcome to our physics death study. We're going down the rabbit hole and exploring Millikan's experiment. Millikan's oil drop experiment originally derived from an idea previously conducted in 1909. Millikan was anxious and under the pressure and desire for a scientific achievement while still in university. This then led him into a series of collective failed experiments, but alongside Harvey Fletcher, his graduate student, Millikan utilized these attempts to approach his results. Millikan's oil drop experiment revolutionized modern-day physics, providing the scientific community a quantitative value for the charge, explored the size and the measurement of the electric charge. Oil was used rather than water to avoid the tendency of evaporation while the experiment was being performed. The experiment explored the nature of electrons by perceiving its characteristics when exposed to a charged platform. The formula Q equals to m times G over E was derived from the nature of the results, where Q equals to the charge of the drop, m equals to the mass of the drop, G equals to the acceleration of gravity, which equals to 9.8 meters per second squared, and E was the applied electric field. Millikan varied the strength of the X-rays, ionizing the air so different numbers of electrons would jump onto the oil molecules. What he observed was that the charge of an electron was always a multiple of negative 1.6 times 10 to the power of negative 19, the charge of a single electron that is still used today in modern physics. An atomizer sprays mist of oil droplets in the upper portion of the chamber. Then, due to gravity and air resistance, some droplets fall through a hole in the top metal chamber. The metal plates can acquire a positive or negative charge when an electric charge is applied. Therefore, when the oil is exposed to its radiation, it requires a negative charge. A viewing microscope with sufficient light would illuminate the oil drops to make them visible to the human eye. The mass of a single charged droplet is calculated by how far it falls.